mean by saying that you guys have done a good job. You have really covered a lot of some good stuff, and we hope and still pray that the services that you have covered are services that you guys will not forget. Okay, you guys will not forget those services. So today we'll be doing a couple of topics. They are very short topics. Like we will start with infrastructure as code. Then we will talk briefly about JSON and YAML, and then look at AWS CloudFormation. Those are the three topics that I'm going to cover this morning. And then in the afternoon, hopefully, we are going to be looking at AI and ML services in AWS. We'll be looking at AI and ML services from AWS. So, let me check something. Good. We are good. Exactly. Nice. Awesome. So let us briefly look at infrastructure as code. Let us briefly look at infrastructure as code, and just to compare it with something that we've always done. You know, in all of our labs, the labs that we've been doing and the various things that we have had an opportunity to do in the cloud, we've been doing them through what we call ClickOps. So when you come to the cloud and then you hear people speak about ClickOps is simply provisioning your infrastructure by clicking or accessing your AWS account through the console. And then when you access your AWS account through the console, you then go ahead and, let's say, for example, you provision an EC2 instance, or you create an EC2 instance. Then this EC2 instance, you configure it, you give it, you choose your AMI, you choose the various things that will make it run, including allowing traffic in various ports. All that you do them through ClickOps by clicking. That's what we call ClickOps. That is not a very efficient way of doing stuff, especially when you're working at an enterprise level where the number of servers you're provisioning or the number of servers you're managing exceed the normal numbers that you would do if you're doing a personal project. In a personal project, maybe you might find yourself working with a max of 4 instances at a go, but in an organizational setup, you might find yourself working with tens, hundreds, or even thousands of instances at any given time. So one of the ways that you are encouraged to provision your infrastructure at an enterprise level is by use of what we call infrastructure as code. You know, infrastructure as code, commonly abbreviated as IAC or IAC. IAC or IAC. So let us look at the objectives of this short class. So by the end of this lesson, you will learn how to describe infrastructure as code and the value that it creates. And the key term that you will meet over and over from this point onwards is infrastructure as code. Infrastructure as code. So infrastructure as code is normally used for what we call resource provisioning. And you see, when you go and create an instance in your AWS account, we say that you have provisioned an EC2 instance. So also get familiar with that word, provisioning. So infrastructure as code tools are normally used for resource provisioning. So the infrastructure resource lifecycle begins with resource provisioning. To streamline the provisioning process, use the principle of infrastructure as code. So an example of an infrastructure as code tool that is native to AWS, it's native to AWS, meaning that it is an AWS service, is what we call AWS CloudFormation. So it's called CloudFormation, and I remember telling you guys that I'm really psyched on, or rather, I'm normally enthused to see how AWS names its services. They are so memorable. Like for example, you see CloudTrail trails people. Yeah, CloudWatch watches something. CloudFormation forms something. You see, so we have AWS CloudFormation that you declare the resources that you want to provision, or you list them in that template that you are going to write. And then when you run that template, it is going to create those resources for you. So you don't need to actually go and say, now for this EC2, I go click here, choose this AMI, do this. No. You write it down. It is like a recipe that you give to a machine. Fun fact, the other day, a friend of mine was telling me that there are these machines in China that will soon hit the African market, machines that can act as a chef. Yeah. So you just give it the instructions of what you want to cook, you give it the ingredients, and then it gets to cook the meal for you. It gets to cook the meal for you, following the instructions that you've given. So think of it that way. Same way, apply that analogy now to this CloudFormation template. Here, you write what you describe how you want your cloud infrastructure to look like. You say the number of instances you want, the type of instance you want, the key pair you want to use, the connection, if you want it to have an RDS, if you want it to have an S3, if you want it to have different security levels, all that, you define it. It's the same way that you would have a recipe, a cake recipe. You say, I want it maybe to be a chocolate cake. For it to be a chocolate cake, it needs to have A, B, C, D. You put all those things together in that recipe, so that finally, when you give it to the machine to cook it for you, the final product that will come out of the process will be a chocolate cake, not a velvet cake, because you wanted a chocolate cake. So similarly, in the cloud, if you want, say, to have a three-tier architecture, or a three-tier you want to make sure that the final product you have of the resources you provisioned are grouped into 3 tiers. And by 3 tiers, we mean sometimes you have you have the database tier, you have a private tier with maybe, let's say, your EC2 instances, then you have a public tier. So those 3 tiers, you see, those 3 tiers reminds me of a cake that has three tiers. So you tell yourself that this is what I want. So you have, first of all, to think it, you have to imagine it, you have to have it in mind and write it down and say, this is the kind of resources that I want, or this is the kind of a formation that I want finally for my cloud workloads. So if this is the workload that I want, then I'll sit down and ask myself, for me to achieve this build, for me to achieve this kind of an infrastructural setup, then how what are the resources that I need? Then once you sit down, you now bring and say, I need an EC2 instance, or even this EC2 instance, yes, maybe I'll have one EC2 instance right now, but later on, I am forecasting, maybe it is an e-commerce site. I think I'll need like 2 instances instead of 1. So you change that, you scratch the 1 and say, I'll need 2 instances. These 2 instances, I want them in 2 different availability zones. And then you say, because I don't want to get back to it when it overloads, and say, maybe add other instances, I'm also going to define an auto-scaling rule using an auto-scaling group. Then I'm also going to put in a load balancer, and we all know the work of a load balancer. This load balancer, I want to make sure that this load balancer also has health checks enabled. You understand? I want these health checks enabled. And then, because I'm going to be collecting some information from the people that will be visiting my site, I want this information to be written into a database. And because I'll be using a database, I want this database to have a replica. This replica will make sure that in case my primary database fails, then the secondary database, which is the replica, will pick up. So I'll have that one. You see, I'm thinking around what I'd like to see in my system, in my system. So it is, yes, it is a web application. But now, even in that web application, it's an e-commerce site. Now, this e-commerce site, I'm trying to think in the cloud, what are those resources that will support it? What are those resources that will support it? So once I sit down and then I say, these are the resources that are going to support it, I can now write them as code in what we call infrastructure as code. In something like, for example, for AWS, you have what we call AWS CloudFormation, and we will be talking more about AWS CloudFormation later today, later in this session, in this morning session. So the creation process of infrastructure resources needs to be consistent and reliable. Infrastructure as code is a framework for implementing such disciplines. AWS CloudFormation is a service for creating infrastructure using code. So here are some examples when repeatable, consistent deployment are needed. Number 1, the creation of replica environments for experimentation of new services, testing in a mirror of the production infrastructure, or quick deployment of recovery environment after a disaster. So notice this. Once you've written your CloudFormation template, you can take that same template, tweak a few things, and then launch that same that same environment in a different account, and then use that account maybe for testing. Maybe you want to add a new service. So in our e-commerce site that we are talking about, you take the environment, you know that you have this working environment, this template that is working, and you have labeled it the way I like labeling my own templates. I can label it as working template -version 1. Then I take that working template, I come and then I launch it in a different environment. Then I add the new the new services or the new feature that I'd like to add, and then I try running it, and then I see how it performs. You know, it's always important to test things first before you take them to production. You understand? For devs in the house, you know this principle. Always test your application right from version 0. You test it first in the test environment before bringing it to production so that you see how it performs. Then once it works as it should, then you can roll it to production. You know, you can roll it to production, and there are different deployment methods that you can use to bring in these new improvements to your feature, so that to make sure that yes, the new features are coming in, but again, you don't take everything. You don't go offline for you to implement new features. You know, you don't go offline for you to implement new features. What I'm about to say is okay. What I wanted to say is above this course, those things you will start meeting them at the dev level and at the DevOps level, where we are talking about different deployment strategies. You know, but just remember that when you have new features that you want to implement in your system that's already running in production, it's very, very important for you to first of all test it, and make sure that it passes all the tests before you bring it to the prod environment. Now, when I'm talking about prod, for people who are not devs, prod simply means that's where your application is running and is now available, generally available to users. You know, if it's a web application, let's say, for example, again, sticking to our e-commerce site example, if it's an e-commerce site, this e-commerce site is generally available to all your users. So that is what is running in production. But if it's running in test, then it is not available to all your people at the same time. There's a deployment strategy that allows you to do kind of a beta test, where you can make an application with improved features available to a small how do you call it? A small number of users, just to test it first and to see how it supports, you know, before you now roll it out to everybody. So before you roll it out to every other user. So testing is one of the ways, just to create that test environment is one of the important reasons why we should really adopt infrastructure as code. Then number 2, creation of temporary environments for demonstrations. Again, this is very similar to creating replicas for experimentation. So this one here, we are told typically when a service is being demonstrated, it is done using infrastructure that is not a mirror of real environment. With EAC, a copy of production can be quickly deployed and used for demonstration. Again, when you get out of this course, there's a possibility you might actually land a client, and this client might want you to demonstrate to them, to show them that yes, you are saying that that let's say, for example, my e-commerce site can be supported in AWS, but I want you now to show me how it works. That is why back in the day when I was working with an APN, an Amazon Partner Network, we used to do what we call proof of concept, POCs. So for a proof of concept, what you do, you take an application, you take the client's application, and then you run it on the cloud at the expense of AWS. So AWS gives you a budget and tells you that, by the way, you can access these paid services, but now use them sparingly, applying frugality, and then make sure that you are able to support the customer for, let's say, a month, so that they can see that indeed we have the capacity to run their applications in our cloud. So when you do that successfully, and the client is and the client gets a feel of a feel of how it feels to run the application in the cloud, they get the metrics. They get the metrics in terms of cost. They get to see things like availability, things like reliability, all those things that we talked about, the well-architected framework, they see it in practice, then that gives them the conviction that indeed AWS has capacity to run their applications in the cloud. So they then move on now to signing the contract, and then now it's now possible for us, back then working with the APN, now to migrate them fully to the cloud and have them run their applications. So when you're doing such things, when you are trying to demonstrate, to show, for example, you have this IoT application, you want to show how it works, you want to show how it will work in the cloud. The best way to do is to take, is to mirror a prod environment, mirror a prod environment for them to see, so that they can actually see that, well, in actual sense, this is how it will be running. This is how it will be running. Then, because, again, for devs, again, talking to devs, it beats logic for you to run things in the local environment to try to convince a client that I'm going to run this thing in the cloud, without you taking them to the cloud and them seeing that application running in the cloud. I don't know if you've heard this joke that it is working fine in my system, and then now when it leaves your system and goes to a different system, say it goes to a different environment like the cloud, it fails. So it's very important for you to show them that I have configured everything is running right in the cloud. Then number 3, to lower cost, development environments for programmers can be stood up when needed. Then when it is not needed, the environment can be deleted. This flexibility not only saves money, but also ensures developers are creating software that will work with the current production system. Yes, lowering cost, cost is a big concern for organizations. Cost is a very big concern for organizations. So you don't need to have an everlasting, ever-running development environment when you are not developing. So when you're not developing, you can tear down that environment and then spin it up in a matter of minutes. In a matter of minutes, you can spin up a development environment in a matter of minutes when needed. So remember, the principle is only have environments or only have resources running in the cloud that you are using. If you are not using them, you can tear them down. And you see, you tear them down when you're using EAC, it's very easy for you to spin those environments up at a moment's notice. At a moment's notice. Now, I know we are talking about CloudFormation. Let me tell you about another EAC tool which I promised to talk to you about it just in passing. We have an EAC tool called Terraform, and Terraform is cloud agnostic, meaning that you can use it across different clouds. You can use it in AWS. In fact, there's a full documentation which I'll give you a link to it later. Terraform for AWS. So Terraform for AWS, it shows you how you can use Terraform in AWS. So Terraform is used to provision resources. It's an EAC tool. So with Terraform, you can actually spin up an environment and tear it down in a moment's notice. So even when you guys start doing your portfolio projects, your own projects that you'd like maybe to showcase to a future client or a future employer, I will really encourage you guys to develop a good understanding of using infrastructure as code. It shows you as an expert. It shows that you know up and above what other CCPs know. What other CCPs know. So it's very, very important to get into that. Now, I think I might forget to say this, but let me also say it here. There's another book. I always like supporting guys who are willing or who are eager to go up and above and learn some more. So there's another book that I'll give you, but I encourage you not to read it right now. You will read it after your exams as you build your expertise in infrastructure as code. It's a Terraform book. So I'll give you a book that you can follow through and learn Terraform from scratch. You can learn Terraforms from scratch and you'll become so good at it. You'll become so good at it. And let me assure you, even as a cloud engineer, and knowing infrastructure as code, and when you get into DevOps, you'll discover that DevOps has many tools. I remember when Joy covered it, she talked to us about the different tools or the different classes of tools that DevOps engineers use. So even in DevOps, you'll come to discover that Terraform is ranked as the #1 infrastructure as code tool. So there are other tools, yes, but Terraform is ranked as #1. And now when you come to AWS, we have CloudFormation. So you can use CloudFormation, you can use Terraform. The choice is yours. The choice is yours. Personally, I use both of them depending on the circumstances. Depending on the circumstances. And also remember, use cases are also important. And sometimes you'll even land a client that will tell you specifically, I want you to use, for example, CloudFormation. So having an understanding of both of them is very, very important. And because this is an AWS course, we are talking about CloudFormation, and we will get to see how to use CloudFormation over and over again. Now, after infrastructure resources are provisioned and infrastructure is up and running, address the ongoing configuration management address the ongoing configuration management needs of the environment. It's very important for you now to move from provisioning. You are provisioned. Now you move to the next step. And the next step here that you're talking about is now about configuring what you have provisioned. So you must provision first before you configure. You cannot configure what you have not provisioned. There is this. I was in this study group with some good friends of mine. We were learning DevOps. And of course, we were doing we were learning CSE and ISE. So CSE is configuration as code, and ISE is infrastructure as code. So someone came up with a very nice analogy. And this is the analogy. And I've actually seen it on LinkedIn. Someone might have eavesdropped in our conversation and then took it to WhatsApp, but no, not WhatsApp, to LinkedIn. But they must have had some very long ears, because those guys, I think they were Russians or Ukrainians who wrote it on their LinkedIn. So this friend of ours reminded us that the easiest analogy to explain how ISE and CSE work together, and by CSE I mean configuration as code. So and we were using two tools specifically. For ISE we were using Terraform, and for CSE we were using Ansible. So Altuambia, this is what she told us. She told us that think of provisioning as a builder, or rather a real estate company that comes to build you a house. So building your house is what we call provisioning. Building the house is what we call provisioning. So when they come to build the house, they'll just build the house, put the basics, put the windows where the windows are supposed to be, maybe make sure that the bedrooms are bedrooming, the bathrooms are there, everything is there. And then later on, now when you want that house to really, really stand out, you will bring in the configuration managers. The configuration managers are what we call the interior deco guys. So these interior designers will come and now design the interior of your house. So Ansible or CSE tools are what we call the interior designer. So they'll come in and design your house to your liking, the liking that you have. Maybe you want the finishes to be finished with different things, stuff like that. So they'll come and do all that, all that. And then she went forth to remind us, that there are instances where you will get that a configuration manager is coming to configure a house that they think has already been provisioned, only to find that that house has not yet been provisioned. So they might have to, because they already won the contract, they might have to come up with a structure that they can configure. So they'll build something that is not up to standard, okay, not as robust as what the real builders will have built, and then do the configuration with it. So that one, I believe she moved to that extra note, because Ansible in itself can also be used for provisioning, but that is not its core strength. Its core strength is in configuration management. Its core strength is in configuration management. So those are just some of the tools that you guys will get to learn. And as I told you before, I like doing fast mention, so that now when you get to it, maybe even in a later class out of this course, you will remember that, by the way, Pat told us something about ISE and also mentioned something about CSE. Kumbe, this is the Ansible that he was talking about. This is the Ansible that he was talking about, and this is what Ansible does. You understand? So we are saying that after you have provisioned your resources, then you need a configuration manager to come in and configure your resources properly. Let's take an example of an EC2 instance. Yes, you have your EC2 instance. It has been provisioned. Well and good. But now you want to configure it. Maybe you want to make sure that we have HTTPD running in it. So you can have the code that runs HTTPD either in your user data, or you can come and define it in the configuration as code tool. And then now when you run this configuration as code, it will now, okay, one of the things that this configuration as code has, it will have, let's say, some details of the EC2 instance where it needs to go and configure. Same way, if you are calling in an interior designer to come and design and do interior design for your house, and you have multiple houses, it's very important for you to specify it is house number A, not house number D. So they will come and do configuration for that. And this analogy can be applied in the cloud, in that you might be having different AWS accounts. Yesterday, we talked about organizational units. So you can have different AWS accounts. So you need to give it the right address, point it to the right AWS account, to the right instance inside that AWS account, where it will go and do the configurations for you. Yeah, for you. So in AWS being a thoughtful cloud provider, has a number of services that can also help you in configuration management. So I've talked about Ansible, which again, like Terraform, is cloud agnostic, but now cloud specific, and specific to AWS. We have AWS Systems Manager, and you have AWS OpsWork for Chef Automate. You know, Chef Automate. So Chef is also used as a configuration manager. And both Chef and Puppet, those are also cloud agnostic tools, but similar to Terraform, where I've told you that there is Terraform for AWS, there's also the way that you can integrate Chef and maybe the likes of Puppet with your AWS account. I hope that one makes sense. So after you provision your infrastructure, after you provision after you have provisioned, give me just a second, guys. This power code is messing up a bit. Okay. So after you have provisioned your infrastructure resources and the infrastructure is up and running, you must address the ongoing configuration management needs of the environment. Consider the following situation. A release manager wants to deploy a version of an application across a group of servers. If problems are encountered, the release manager wants to be able to roll back to a working version. That's very nice. A system administrator receives a request to install a new operating system package in a developer environment, but to keep the other environments untouched. That is also possible. An application administrator needs to periodically update a configuration file across all servers that host an application. That is equally possible. So all of these three scenarios that we are being given here are possible, and they can be implemented using what we call CAC, configuration as code. You know, they can be done using configuration as code. So one way to address all of these situations is to return to the provisioning stage, provision fresh resources with the required changes, and remove earlier resources. This approach, which is known as infrastructure immutability, ensures that the provisioned resources are built anew according to the code baseline each time a change is made. This process, the process of infrastructure immutability, reduces configuration drift. A configuration drift, not this, a configuration drift means that the actual configuration of the resources differs or has drifted from the expected configuration. You know, and there are many different instances where configuration drift, where you can find that your environment or your workloads have drifted, and this is the case. Work with me. Now, consider this. You're working in an enterprise level organization, and then you are not the only person that is working in that particular AWS account. Yourself, you have provisioned whatever you provisioned using infrastructure as code, but now you have another colleague that decides that now, because I need an extra instance, I'm going to provision another instance using Cloud ClickOps. So it means that your environment has changed. You know, whatever is in your environment has changed because there is a new instance that has been provisioned, but this instance is not being managed by your IAC. It's not being managed by your IAC. So there is a drift. A drift has happened. Someone has provisioned something using ClickOps when the initial environment was provisioned using IAC. So in organizations, and I saw this one in an organization where I was working, there is need for the lead developer or the lead DevOps engineer to define the standards in which all the people that will be working in AWS account with AWS accounts adhere to, all the standards that they have to adhere to. One of the standards that was actually implemented in that organization is that all provisioning of resources must be done using IAC. And that is a very good way to avoid drift, because again, you see, remember, there's this principle that we talked about. We said that if you are not using a resource, tear it down. Only have it running when you're using it. So you can imagine that you have this instance, and don't think that these instances are cheap. There are some instances that are very expensive. So you have this additional instance that has been provisioned, is not being managed by IAC, and then you finish what you are doing, and then you run the commands that now automatically tears down the entire the entire setup, and then this other EC2 instance that is not being managed by IAC will not be teared down. Why? Because, is it teared or torn? Okay, it will not be brought down because it's not being managed by your IAC. It's not being managed by your IAC. And if you forget to go and then tear it down using ClickOps the same way it was created, then you risk leaving something in your environment that will continue to incur spend without your knowledge. You understand? Without your knowledge. So I'm trying to encourage you guys as far as possible, as far as it depends on you. If it depends on you, or if you can, or if you walk into an organization and you can convince guys to abandon ClickOps and use IAC, the better for you and the better for the organization. Actually, I did that in one of the APNs that I've worked with. I went, okay, my work, let me just pour kidogo mtama. My work entailed going in and then looking at how they are doing things in the cloud and then advising them on the best way to do certain things. So the first thing I did, being a Terraform associate myself, I went in and then I looked at how they are provisioning their resources. I discovered that they're doing them through ClickOps, and I also discovered that at some point they used CloudFormation, and then someone introduced Drift because they again went back to ClickOps. So I advised them and encouraged them to use IAC. I no longer work with them, but I can tell you that is one of the changes that I made, and they adapted that and they are continuing with that practice, which is actually best practice for any organization, especially for big organizations. Yeah, medium to big organization, IAC is very good. Even you, for you to actually get a very good understanding of how IAC works, I'd like to encourage you, when you get to doing your portfolio projects, start from IAC. From the word go. Start with IAC from the word go. Even if it means, even if you just want to spin a single instance, try and see how you can write a CloudFormation template for that instance that you want to spin, and then run it, run your code, and then see how it works. And then tear it down, and then run it again, tear it down. And then from there, you can now build on that CloudFormation template and add more resources and see how it works. You understand? I hope you guys get what I am getting at. So there are times, however, when you might want to take a different approach. So remember the first approach, we are talking about, yes, you want to change stuff. And because maybe you had your starter code, or rather your user data in the instance, and that instance and that user data is in your IAC, in your IAC template. So you have to tear down everything, amend the user data, and then go back and then now run that environment. It will now create a new environment with the updated user data. But now we are saying that there are those times when you might want to take a different approach. So some environments have high level of durability in which transactions or data are stored permanently. Therefore, committed changes to a database can be recovered or reconstructed reconstructed entirely. For such environments, it might be preferred to establish ways to make incremental changes to the current resource instead of reprovisioning them. You understand? You can make incremental changes. You can manage these changes by using AWS Systems Manager and AWS OpsWorks for Chef Automate. So when you are talking about Systems Manager, this gives engineers insight into the existing AWS infrastructure. It includes automating many repetitive tasks and shortening the time to identify operational issues. So System Manager also has automation capability to help improve accuracy and efficiency of maintenance tasks. Later on, when you guys get to the associate level certifications, you'll discover that a tool like Systems Manager can work together with what we call runbooks. So runbooks are just definitions that you've written, maybe your standard operating protocols, you write, and then you convert them into a document, you call it a runbook, and then you give it to Systems Manager. So Systems Manager will be checking your environment to make sure that your environment meets your standard operating principle or protocols. You understand? Then like Systems Manager, we have OpsWorks. AWS OpsWorks for Chef Automate can help automate and improve efficiency of many tasks by providing a managed Chef server and tools to help with deployment, testing, security, as well as visibility and status of your resources in cloud environments. So it's very, very important for you to have entire visibility of what is running in your cloud environment so that you know this one is running well, this one has issues and it needs my attention, so I go and I attend to it. This one is secure, this one is unsecured, I need to attend to it, I need to make it secure. I need to make it secure. So, as I promised, I told you that infrastructure as code is such a short course, is such a short unit, because here, remember, it's just an introduction to infrastructure as code. After your CCP, you will get to use infrastructure as code tools that are specific to AWS, the ones that we've mentioned. You'll also use CSC tools that are specific to AWS, and you'll also use cloud agnostic tools. You know, cloud agnostic tool, when we talk about cloud agnostic, we say that they are not tied to a specific cloud vendor, but they support different cloud vendors. You understand? Yes, yes, yes. So that is very, very important. So we have some key takeaways. For me to at least take a breath, I need someone to unmute and read this for me, please. Somebody? Somebody?
Hi, Patrick.
Yes, yes. Hi.
I'll read for you.
Okay, please do.
Use infrastructure as code to automate resource provisioning in the cloud consistently and reliably. AWS CloudFormation is one of the AWS tools for managing resources with infrastructure as code. After deployment, you can manage the infrastructure using other tools such as AWS System Manager or AWS OpsWorks. In both cases, use code to ensure consistency and reliability.
Awesome, awesome, awesome. So you see, we are being encouraged here to use infrastructure as code to automate resource provisioning. And the reason why this is a good practice or a best practice is because it ensures cloud consistency and reliability. Okay. So just know that as you advance in your journey in the cloud, you're going to meet very many tools. Don't let them overwhelm you. Just learn a tool at a go, experiment with it, build a small project with it. That's the best way for you to master a tool. Okay, that's the best way for you to master a tool. And so we are done with infrastructure as code. How are we doing on time? We are good. We are good on time. So we are done with infrastructure as code. We will cover JSON and YAML when we come back from the break. But before we go for that break, let me talk to us briefly about CloudFormation because we've mentioned it. Let's just look at CloudFormation kidogo. But do you have any questions? Do you have any question on infrastructure as code? Any questions on infrastructure as code? Good to see that those who are not with us when we started the class are here. Nice, that's nice. Thank you for joining us. Thank you for joining us. Let me see, which one was longer? One of these was longer. Any questions? Any questions? Somebody talk to me. Any questions? If you don't have a question, I'll ask you a question. Let me see. Ansible playbooks. Nice. Good analogy, Gideon. Nice. Ansible is used to automate management of multiple servers at once. Management automation, yes. Code can also be versioned using versioning tools such as tools. That's very true. You'll also access and okay. That is to do with Canvas. Okay, good. Awesome. All right. So let us do YAML and JSON first, because I want to cover this within the shortest time. Then I'll release you guys for break. I don't want to break. I don't want to break it in the middle. So we are going to look at JSON and YAML. Who amongst us have ever used JSON and YAML before? Who has ever used JSON or YAML before? Yeah, Gideon, you say that you've used JSON or YAML. Yeah, let me see. Tukona mwingine. Is there any other person that has ever used JSON or YAML? You find the syntax of YAML and JSON a bit advanced. Yeah, they are advanced. And again, Salem, because this is an introductory course, we have to introduce you guys to these concepts, because they are pretty important. Okay. We have to introduce you guys to these concepts because they are pretty important, and you're going to meet them. Especially, reason why I've even decided to take a step back and do this before we do CloudFormation is because you'll discover that that most templates we use, be they CloudFormation templates, be they Kubernetes manifest, and all the other templates that we use, most of them use the YAML data serialization format. So both JSON or JavaScript object notation and YAML. Here I see they call it YAML ain't markup language. In another place you'll find they say YAML is yet another markup language. So I don't know which is which, but both of these are actually data formats that are commonly used in automated and repeatable deployments. Automated and repeatable deployments. The purpose of automation is to make sure that we find a way of having these repeatable tasks being done for us, so that we are left to focus on the core of our business, or we get to focus on things that require human intervention. But things that can be automated needs to be automated. Now, generally speaking, when you talk about automation, there are 3 levels of automation. There is proper automation, there is over automation, and there is under automation. Now, not everything needs to be automated. You don't automate everything. There are certain things that will require you as a human being to maybe do a sign off before you allow maybe the next process to proceed. So that is where you now really need to know how to properly automate your systems. And again, you will get to learn more about this when you get to the associate level. But here we are just looking at a high-level overview of what JSON and YAML are, and they're saying that they are data formats that are commonly used for automated and repeatable deployments. So again, objectives. What are the objectives of this course? So the objectives here, at the core of the lesson, you will learn how to describe basic syntax of JSON and YAML. Then you'll explain the advantages and disadvantages of JSON and YAML data formats. The goal here is to be able to identify JSON and YAML formats and understand the basic syntax of both formats. Now, fun fact, you are not going to answer any question on this topic in your exam. Maybe the closest you'll come to answering questions here is if a question on CloudFormation comes your way. But just remember what we said. We said that for CCP, you will be asked about AWS services. So worry not. This is just for your own enrichment and also to give you a good foundation on how to distinguish between YAML and JSON. So these are syntaxes that are used for defining cloud infrastructure. And now the language of the infrastructure is what we call JSON and YAML. And both of these are declarative languages for creating cloud infrastructure. We've talked about infrastructure as code as a method to declare the resources that are needed in the cloud, in using text files. So you will use text files, and these text files will take a .yaml extension. You know, the same way when we were doing Linux, we were creating empty files and then we were giving it .txt, for example, .txt. So here, for our template files, we'll have them a .yaml file. And then you'll discover that when we write policies, let's say I am policy, for example, we are writing them in JSON, so they are .json. .json, you see .yaml.json. So those are file extension. Our file extension tells the interpreter how to read that file. So you need to have the right interpreter in your machine or in your environment for it to read that file. I hope you understand that. Okay, good. So JSON and YAML syntaxes are used by AWS to declare resources in the cloud. It enables the definition of simple to complex infrastructure in text. So when you start doing your simple projects right now, you fall under simple. Then as you grow in your skill, you'll then move to intermediate level and then to expert level, where you'll now be writing complex infrastructure in text. You know, so understanding the syntax of JSON and YAML are required to build infrastructure as code. So if this is a language that is needed for you to build infrastructure as code, then you have to understand how to use JSON and how to use YAML. That is very, very important. Okay, so introduction to JSON. I'm just going to brush through this. It's quite a lengthy one, but I'm just going to brush through it. Just make mention of what I deem important. So, and similar to what we did in Python, when we were talking about the syntax of a language. So even for JSON, it's very, and YAML, it's very important for you to know the syntax, how it's supposed to be written, you know. So for JSON, we write JSON using what we call key value pairs. So you write a key followed by a colon, and then you write the value. And remember the data structure that we talked about. We talked about strings, data structure of type string, data structure of type, remind me hapo kwa chat, what other data structure did we talk about when we were doing Python and programming? If you guys were in class, what other data structures did we talk about? Nice, Rich. I like it. I can see you have used JSON to upload bulk data to Firebase. Awesome. That's awesome. People, talk to me. What other data structures? Sama ilifika Python, after you finish Python, you had it's not coming to exams, you highlighted all and deleted. Yeah? Is that what you did? Int, yes, int for integers, float for numbers with decimal points. Yes, and we've already talked about string. Yeah, now, yes, wonderful. So we are saying that the syntax for storing and transporting data that contains, for Java, for JSON, it is syntax for storing and transporting data, and it contains 1, key value pairs, and 2, arrays, which are lists and other objects. You know, when you combine list and other objects, you can actually build an array. So look at that syntax. So we have that curly braces. You see that kind of a bracket is what we call a curly brace. So we start with the curly brace, then we write our key, let's say key 1, followed by a colon, and then small space, 1 space, and then you have the value, like value 1, inside what? Quotation marks, comma, and then we have the next value, the next key value pair. So we have key 2, colon, and then again, space, open quotation marks, value 2, and then we close it with what? With another curly brace, you know? So that is very, very important. That's like the syntax. And then for arrays, look at that array. So we have an array, colon, array, colon, space, then we have a square bracket. I've had in another place them being called angular brackets, but just call them square bracket. So in that square bracket, you have your 1, 2, 3. So that might represent a list, for example. That might represent a list inside, a list that now creates that array. Now, look at this. Apart from it storing, it also enables the exchange of complex data structure in a single document. It enables the exchange of complex data structures in a single document. So here, you are able to combine multiple data structures in one document. Now, some of AWS services covered in this module, such as CloudFormation, support JSON as a data format. AWS CloudFormation is a service for writing or changing templates that create and delete AWS resources together as a unit. Remember what we said? Remember what we said? We talked about the beauty of using CloudFormation. So you declare everything that you want to declare, and then now you can use it to do what? You can just run that template as is, and it will delete everything or create everything. For it to delete, first of all, it needs to create. Now, to provision and configure your stack resources, you must understand AWS CloudFormation templates, which are formatted text files in JSON or YAML. In JSON or YAML. Therefore, in this section, you will learn the essentials of JSON. The essentials of JSON. So JSON is a syntax for storing and transporting data. It's a text-based format, so it is human readable. You are able to read the same way you've seen key and value. You are able to read. JSON documents are easily written. They store key value pairs and arrays of data. A key value pair is a set of two linked data items. For example, a key is a unique identifier for an item of data. Let's say, for example, our key is students. Then value, data that is identified or a pointer to the location of that data. So when you're talking about the data that is identified, our key, we've given it an example of student. Then you can have value as Clinton, Rich, Sandra, Sharon, Beverly. You see, Salem, all that. So the key is student, but now the value are the names of those students. You understand? Or you can even say key, let the key be student name, or let the key be student name. Then now you have Salem, you have Ridge, you have Clinton, you have Sandra, you have Abby, and remember these values are separated using what? They're separated using commas. I hope you understand that. Okay. Then the data that can be structured, the data can be structured so that you can store complex data structures in a single JSON document. The key use case for JSON is that it supports the simple exchange of complex data between computer systems. Just the same way Rich has given us an example of uploading bulk data to Firebase. I did not take bananas. What? Uploading bulk data to Firebase. So that bulk data, you might find that it had different, it included different data types. There were some that were some that were of data type int, some that were of data type float, some that were of data type what? Data type string. But all of them were able to be uploaded. So that's a possibility. Look at that example. So we have a student name as our key, we have a location, and then we have favorite sports. So look at that. So we have Maria, USA, tennis. So a student named Maria in the USA, her favorite sport is tennis. Another student called John in the UK, his favorite sport is cricket. Another student called Diego in the USA, his favorite sport is basketball. Then we have Kwesi in India, his favorite sport is hockey. So this is data in rows and column. But now come see how you can represent this. Yeah, you can represent this in JSON format. So we have sport choices. So that is sport choices. So sport choices, we start with the student name, So student name is Maria. Location is USA. Then favorite sport is tennis. You see that? You see that? I hope you are able to see that. Then again, we come down, see a comma. Now we are separating this key value to this other key value. Now we have another student name. Now details for a different student. Now the student name here is John from the UK, cricket. Then come down, see again student name, Diego, location USA, favorite sport, basketball. And then finally we have Kwesi from India, playing hockey. So this data has been written in JSON format, and this is what you have as your JSON formatted text. And it's very important for you to see how this is used. These curly braces, you know, curly braces, you see? So we have curly braces opening, we have square braces, square brackets at some point, and any bracket that we open must be closed. You know, like this is closed here, this is closed here. You understand? Yeah, and this is closed here, this is closed here, and after every declaration, let's say, for example, we finish declaring details about Maria, we end, after we've closed it, we end it with a comma, and then we go to the next one, comma, comma, comma. So this syntax, we are just introducing you to them, but you will meet them in practice. You will meet them in practice and you'll enjoy them. Okay, you'll write so much of this. And lucky for you guys, you are living at a time when vibe coding is a thing. So writing these things will just be a breeze. But it's always important, even if you decide to go the vibe coding route, which is not a bad thing to do anyway, you should also know the basics so that in case you start getting errors, you will know, by the way, there is a problem here. Maybe there is a comma that was missing at a specific point, or I did not close a bracket that I had opened before. So what you commonly see is data in columnar form or in columns, such as in tables. However, to store table data in a way that is easy for machines to ingest, parse, and distribute, it must be stored in a non-graphical way. It must be stored in a non-graphical way. So what you've seen us show you in terms of how JSON converts tabular data or columnar data into JSON, that's what we call a non-graphical way of presenting data. So JSON provides a way to store data objects in a human-readable text document, as illustrated in the example. So you have columnar data from a table, which consists of 3 columns and 5 rows that can now be converted into JSON. So let's quickly look at advantages and disadvantages of JSON. And some of the advantages of JSON includes the fact that it is lightweight, so minimum syntax and mockup, good for application programming interfaces. So when you are writing APIs, JSON is very good for that. Then easy for humans to read and write because you've just seen key, value, and then you have your array. Then easy for machines to pass and generate. But one key disadvantage is that it has no native support for binary data, such as image files. It does not have support for image files. Yeah, you will get to learn more about that as we move. So some analogy has been presented here. This is JSON building block, an object. How do you describe this dessert? You see, it's a cake. You see, it's a cake. I've been talking about cake since morning because I'm trying to run away from bananas. So here is our cake. You can see this cake feeds 8 people. It's a cake of type chocolate, and this cake is valued at $20. You know, you see? So this is a cake. What is it? It's a cake. It's a cake of type chocolate. We have cakes of type chocolate, velvet, which other ones are there? Blacker foresty, whiter foresty. Which other one? Which other one? Ladies, I expected you to shine here. You know these things. You know cakes. You know cakes. Don't pretend that you don't know cakes. You know cakes. And we know you know cakes. We know you know cakes. Belinda, cake. Tell me one cake type you know. Befalin. I can see you, Angela. Fun. You guys are just laughing slowly. Red see, I told you, red velvet. Imagine red velvet. Is there a black velvet or a white velvet? Red velvet. See, see. People. Tell us. Give us one more example of a cake. Oh, you're not cake people. You know cake. Hakuna mtu amekuwa na birthday all this time. Yeah, this month, ama mmezeeka, mnasemanga birthday for kids. Marble cake. Yes, Sharon. See now. There's also a cake of flavor cocoa pine. Choco mint. See, fun. See, you see? There's also fun. You've forgotten one that is closely named to you, a fudge cake. I also saw another one, Najita Oreo. The cake which you can't eat and have, go away. Joy, your birthday is coming up, eh? People are ready to wash you and give you cake. Blueberry cake, wonderful. See, people know, So that was nice. That was nice. So see, in our example here, we have a cake of type chocolate and it feeds 8 people and its cost is $20. Okay. So consider how you will describe an object, such as dessert shown here. What characteristics does it have? 4 characteristics that describe these desserts are highlighted. Yeah, I know they call it dessert, but some people, and I'll not mention fingers and point names. Some people, when they go to a buffet and they see cake, they collect cake as if cake is the main dish. Yeah, yes. So this dessert, we are told that that its 4 characteristics are highlighted, and you can see them properly highlighted. So now here we have type is cake. What object is this? It is a cake. Flavor is chocolate. Price is 20. Feed is 8 people. So we have our key and our value. You see, we have our key and our values. Okay, I hope you guys have seen that. Simply written, just that, So type cake, flavor chocolate, price 20, feeds 8 people. Okay, cool. So we already talked about these braces. I told you that you should have these braces, and the braces that you see there act as containers. They are the container in which we will have our key value pairs. So our key value pairs for this object, for the first object that we've seen that it is type this, flavor that, price that, and feeds that. So JSON uses universal data structures. An object is an unordered key of, sorry, let me take that again. An object is an unordered set of key value pairs. Then an object begins and ends with these braces. We call them curly braces. Then each key is followed by a colon, and I've explained that. And then each key value pair is separated by a comma. You see, so within here we have our key value pairs. So this is a key and its value, key and its value, key and its value, key and its value. So the first 3, all of them are separated by a comma, comma, comma. This one does not have a comma because it's at the tail end of our container. Okay. Cool. So I'll not belabor this. That is the same thing that I've talked about. And then now see, we have a different cake here. You see? Yes, we have the same cake. Sorry, we have the same cake, but now something has been added. An additional thing has been added. Yes, we agree that it is still object cake. I hope everybody can see that it is still our object cake, and it is still of type chocolate. But now blueberry, which is represented by these things here, this to fruit here, this is blueberries. Yeah, this is blueberries. And mint, this leaf here is what we call mint. This leaf here is what we call mint. If you've never seen mint before, this is mint. Okay, this is mint. This is mint. Mint. So mint, this is mint, sorry, and this is blueberry, and it is used as a topping of this cake of ours. So that's an additional attribute. So what additional attributes could you use to describe this dessert? So we know that yes, it is a cake of type chocolate, but no, it is a cake. That is the type. Then it is of flavor chocolate, but it has 2 toppings. The toppings that we have here is mint and blueberries. So if you wanted to be more specific about this dessert, you could document additional characteristics. For example, it has both blueberries and mint as additional ingredients. So you can have it as this. See what we have now. Type is still cake, flavor chocolate, price 20, feeds 8 people. Additional ingredients that we have here include blueberries and mint. See how we have nested these additional ingredients under the key additional ingredient. So we have the values blueberry and mint because both of them are under that key, the key of additional ingredients. So we have our blueberry and our mint. Okay, so that is good. That's really, really good. So you see now when you are nesting or when you are adding values to your key and you are adding more than one value, then you will have to encapsulate them, or you'll have to cover them inside or include them inside brackets, the so-called square brackets. So a bracket hold arrays. So the arrays here that we have are blueberries and mint. An array is an ordered list of values. So we have blueberries and mint. And then in an array, an array begins with the left bracket, okay, and ends with the right bracket, as you can see. Then values are separated, of course, with a comma. Values can consist of multiple types. It can either be a string, a number, or an integer, an object, an array, or Boolean. Remember Boolean? Boolean is true or false. True or false. Cool. Good. Good, 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 good. That definition is the same. Now, that one brings us to the end of what we call JSON, JavaScript Object Notation. JSON. So you will meet JSON. When you meet JSON pale mbele, I almost said there in front. So when you meet JSON in the future, you will remember that we talked about JSON and we say that it has key value pairs and it has an array, and that you can nest them. You can nest them using square bracket. You can add attributes to your objects using square bracket. And itself, when you're writing the key value pairs need to be separated by a comma, and they also need to be encapsulated inside what we call brackets. What do they call those brackets? Curly brackets. Again, for the ladies, you know what curly kits are, eh? Oh, no, you don't know. You guys are relatively young. You don't know what curly kits are. Curly kits. Let me not reveal the age of some of us here. Curly kits, yeah. Curly brackets, okay? Good. Now, let us talk about YAML. YAML, yet another markup language, or YAML ain't a markup language. So, as I had mentioned before, YAML is normally used when you are writing templates, and the computer understands. And also you, as the person who writes it, you'll also get to understand. When you are doing programming, we say that you need interpreters which will interpret what you have written, what is readable to you, and convert it to a language that the computer will understand. But now for YAML and JSON by extension, these are languages that you write, you understand them, and the computer also gets to understand how whatever you have written. Now, YAML is a human-readable data serialization language, often used for configuration files and used to describe data. It is designed to be portable and works well with common languages such as C, Java, Perl, Python, Ruby, and other languages. So if your favorite language has not been mentioned amongst what I've just read, consider yourself to be inside the other languages. Now, this provides similar capabilities to JSON. Complex data structures can be exchanged in a single document. So that is a superpower for both of them. And again, here we say that some AWS services that are discussed later in this lesson, including CloudFormation, also support YAML as a data format. To use AWS CloudFormation, it is important to understand the YAML format. Similar to JSON, you should be able to understand the structure or the syntax of YAML document to author some AWS CloudFormation template sections in YAML. Okay, therefore, in this section, you will be introduced to the essentials of YAML. The creator of YAML wanted to distinguish YAML from other languages such as Markdown and XML that are often used for markup text, like JSON, and YAML is a syntax for storing data. So like JSON, we say YAML is also syntax for storing data. It is a text-based format, so it is human-readable. YAML documents are easily written. Actually, I find them easier to write than JSON. They store key value pairs, lists, and associative arrays of data. You can store complex data structures in a single YAML document. Yeah, that's what we can say about it. And talking about templates, you will discover that apart from CloudFormation templates, we also have the Terraform templates or Terraform files, the .tf files. So .tf files for Terraform specifically, the need that we use a different language. We use a language called HCL. You guys will learn about it later in your journey. So we don't use YAML there, but now you'll get YAML being used in other places where templating is important. So when it comes to writing manifest for Kubernetes, we will use YAML, okay? You'll use YAML. So YAML is such an important language. YAML, no, not language, but rather, but a data serialization tool. So YAML versus JSON. So for YAML, we say the advantages for YAML include optimized for readability, less verbose than JSON, no braces, fewer quotation marks, supports embedded comments. Many people find it easier to debug. And those many people includes me. I like YAML more than JSON, but there are some use cases where JSON is also strong. Now we have some advantages of JSON, more widely used by other computer systems and easy to generate and pass. It is easy to generate and pass. And again, you guys will get to read through that note. So let us look at the basic syntax. Oh, yeah, good. Sorry. So basic syntax for YAML basic syntax. So a few YAML syntax bases. So it uses white spaces, indentation to denote and create data structures. So don't use tabs. I know there has been that discussion. I saw some people almost, let me say it in Swahili, then I'll find a way of converting it to translating it to English. Kushikana mashati online when they were arguing about spaces versus tab. Spaces versus tab for writing code. You know, sometimes you banter over things. You banter over things, over things that appear inconsequential, or they appear mundane, or they appear easy. But again, you know, we are we are devs. So if we get an avenue to release team, we can release team in arguments such as I prefer tab than spaces. So after you've said you prefer, they tell you it's not a preference, that is the best practice. And then you ask them, says who, and then discussion spirals from that, you know. So kushikana mashati is, who can tell me kushikana mashati is in English? Brawl, or do what? To hold each other's shirts as if you're fighting. I almost say to touch each other's shirt. Hey, well, I should have taken English for breakfast. Anyway, good. So we are saying two spaces is the standard indentation. So here you are encouraged, if you are a dev who does not use spaces, who does not use the spacebar for spacing, please use it here and then go repent later to the to the tabs team. Then add a comment by using a number sign. You know, you remember that alama ya reli, that hashtag. It's called hashtag. What is its other name? A hash symbol, that symbol, you can see it there. I hope you guys can see it. Let me make it a bit bigger. That one at the beginning of the line, so you can add comments using that. And then lists, create a list by starting the line with a hyphen, one item per line. Alternatively, define the list on a single line using brackets. So if you want to define all your items in a single line, you can use a bracket and then comma between the items, the same way we did in JSON. And then create associative arrays by using colon followed by a space. So you have key value, one item per line. Then for strings are normally not in quotes. It's not like what we had before. However, they might be enclosed in double or single quotes. So they are normally not in quotes, but you are allowed to use double or single quotes if you are used to. If for you believe that strings are not strings unless they are in quotes, so you have been given that opportunity to keep your sanity and to do things the way you know how to do and you like how to do. And I think this is a trade-off, especially for those who use tabs instead of spaces. You've already been told to use spaces. So you at least you've compromised here. So here they've allowed you to do things the way you know best how to do. Problem with us devs is that sometimes we become so accustomed to doing things in a specific way, of which when it comes now to being told to do things in a different way, we find it to be a bit tedious, you know. So when we talk about denoting data structures, we say YAML syntax uses white spaces indentation to denote and create data structures. It's important to know that YAML interprets tabs as white spaces, but so you must be careful to avoid using tabs. So if you use tab, that tab will be read as a white space when you create or edit YAML documents. So you know the headache that comes when let's say, for example, a linter runs through your code and then it finds white spaces. That code will not run. You know, that code will not run. So you're told that if you use tab, it will be interpreted as white space. So you're told, please use what? Please use spacebar. And we've also discovered that when you're writing code in some languages and then you decide to use spacebar, then that will now introduce white spaces into your code. You know, so that is why mostly when you're writing code, we are advised to use what? To use tab. Tab is best for writing normal code. But here we are told use what? Use the spacebar. However, as long as your indentation approach is consistent, the document will be valid. Adding comments, you add comments to your YAML file using what we call a array or the hashtag at the beginning of the line. Keep a blank line both preceding and following any commented line. I think that one also improves readability. Yeah, it improves readability. So if you have a comment, you'll have your commented line. Above it, one line should be free. Below it, one line should be free of any text. And then you continue writing right below it. Then when you create your list, we've already talked about how to create your list. You start the line with a hyphen and write only one list item per line. Alternatively, you're also allowed to define an entire list by putting multiple line items on a single line. However, for this, you will have to use brackets and commas, the same way we did JSON. Then when it comes to creating arrays, to create an associative array, use a colon followed by a space. Then you will see an example of this syntax next. Now, defining key value pairs, just like JSON, YAML documents store key value pairs. To define a single key value pair, use colon between the key and the value, and make sure that you're using one item per line. Then, of course, when it comes to creating strings, unlike JSON, strings in YAML are not enclosed in quotation marks. However, you might sometimes see them enclosed in double or single quotation marks. Use quotation marks. Usually, quotation marks are used as escape characters that appear in the string, and that would otherwise confuse the system reading a YAML document. So it's very, very important for you to try and stick to the conventions where you have been told, however you can, use it sparingly. Don't make it a habit. Use it sparingly, because again, we want to make sure that our code is being interpreted right. Look at this example, and here we are not talking about cakes. Here we are talking about the server, web server. So our type is AWS EC2 instance. We are looking at the JSON and we are looking at the YAML at the same time. Look at how we are declaring that type. So you can see for JSON, we have enclosed the type, and we've also enclosed the value, or that is our EC2 instance. Then the properties, see the properties. And then for JSON, you can see we are opening a curly brace where we are going to put our keys and values, and and then for YAML, we just have them one line, one on each of its line: image, instance, key name, security groups, subnet. In some places, you'll see each of those keys, like image has a hyphen before it, instance has a hyphen before it, key name has an hyphen before it, security group has a hyphen before it, and then subnet ID also has a hyphen before it. So this is just a test of these two languages, of these two data serialization tools, and you will get to use them a lot. You will get to use them a lot as we move forward and as you continue in your cloud journey. Good. So we have come to our key takeaways. And I'd like to invite a lady to read this for us. Any lady would like to unmute and read? Any lady would like to unmute and read for us? When I asked about cake, you guys were very upbeat. Now reading, yeah, reading, people. Or should I choose? Should I? Should I? Please volunteer yourself. Prudence, are you in a position to read? Hey. When the class is this quiet, you wonder if you're talking to yourself or someone is hearing you. There are people that have not heard you speak. No, it's not that I've not really heard you speak. By me mentioning you does not mean that I've not heard you speak, Ms. Chome. Amy, are you able to read? Amy.
Yes.
Oh, please read.
Yes.
Why didn't you volunteer and you are able, Amy? You wanted me to volunteer you? Or you are giving others a chance? Okay, please read this for us.
Okay. Key takeaways, we have JSON, syntax for storing and transporting data, text-based format, so it is human readable. Documents are easily written. Stores key values, pairs, and arrays for data. Syntax for storing data. Text-based format, so it is human readable. Documents are easily written. Store key value pairs, lists, and associative arrays for data. Store complex data structures in a single YAML document.
Nice. Today I've learned something new, Amy, that you can actually read YAML as YAML. That's nice. Yes. YAML, JSON. So that is the key takeaway from the two of them. Thank you so much for reading for us, Amy. Asante sana. You've just scored yourself some participation marks. That is awesome. Thank you so much. So that one brings us to the end of this interesting module on introduction to YAML and JSON. So when we come back from our short break, we will be looking at AWS CloudFormation. We will be looking at AWS CloudFormation. So let's see. It is now 10:50. Let's meet back here at 11:20. That is a 30-minute break. Go take breakfast. If you haven't taken breakfast, go test sun. Yeah, stretch a bit, and let's meet here at 11:20. See you guys. Yes, recording. Cool, awesome. So we are going to be talking about CloudFormation, and should time allow us, we will briefly look at this lab and then do a bit of troubleshooting. And then this will be left for you guys to do, and then you'll do this KC. And if you feel, okay, I've looked at this fact-finding exercise. It is good to jog your memory. It is good to jog your memory. Where is it? Here it is. It's good to jog your memory because it looks at different things that we've covered, right from Python, databases, this is just fact-finding, databases, AWS CloudFormation 1. Okay, we are now doing CloudFormation 1, where you were asked to define a YAS, PAS, and that, provide 6 advantages of cloud computing. This is very good for you to do, just to jog your memory. You can do it in your group, you can do it with a friend, you can do it alone. But this is very good because it helps you to see if you really understood the topic, because you see it does not even have multiple choices like cases. So what are design principles that increase reliability, stuff like that. So it helps you see CloudFormation, configuration orchestration, configuration management, building. You see, yeah. And then there's a thank you at the end of it all. So fact finding, this fact finding exercise will also leave it for you guys to try it out. And then there's this challenge lab. This challenge lab, please do it. Please do it because you have to do all your labs. So this one will leave it for you. I'll just this and this. I think these two will leave it for you guys to do. Uzuri, they have like steps that you need to follow. So I'll try and see if time allows, we will look at this one. This is lab 190. So if you'd like to do it with us in class when you'll be doing it, please get your lab 190 running. Get your lab 190 running. Then we want to brush through CloudFormation, AWS CloudFormation. So I have my lab already running here. So I can do start lab. I hadn't started it. I had not started it. Okay, so let's look at CloudFormation. And we said that CloudFormation is our what? Is our IAC tool that is native to AWS. Yeah, good. So having said that, let us look at the objectives of this lesson. So by the end of this lesson, you will learn how to describe the purpose of AWS CloudFormation, then create an AWS formation template and use AWS CloudFormation best practices. I swear I did not take breakfast. I did not take banana for breakfast. So use AWS CloudFormation best practices. So those are the 3 objectives that we seek to meet by the end of this lesson. So some key terms that you'll come across include AWS CloudFormation template and AWS CloudFormation stack. Okay, good. So the challenge of cloud deployment. The challenge of cloud deployment. Before jumping into AWS CloudFormation, let us discuss the potential issues that could come up when deploying in cloud environment. So these are some of the deployment challenges. The first challenge, as you can see, is deploying rollouts across multiple geographical locations. Deploying rollouts across multiple geographical locations, or debugging deployments, or documenting all changes, or updating live servers, or having the ability to manage a rollback, or managing dependencies on a system and subsystem, on systems and subsystems, or deploying repeatable and identical environments. Yeah, because again, when you're working in an organization, there are chances that your needs, the needs for your resources, or rather the needs for your workloads might increase or decrease. So as they increase and decrease, and then you are used to ClickOps, you will be so busy doing things that would have otherwise been automated for you, And aside from that process, taking your time and taking your focus from other important stuff that you would have done instead of doing this mundane stuff, it also has a risk of introducing errors in your deployments, because if you do something over and over, you might assume that yes, but there's a possibility that you might actually introduce errors in your subsequent deployments. But if you have this infrastructure as code tool that you have designed yourself, you have described yourself, you have tested it, and you've seen it to be working, you can use this because it works. In IT, we say if it works, don't fix it. And so because it works, you can use it to deploy yet another environment in another environment. Of course, in some other instances, you might have to tweak it a bit. Maybe you need additional resources that the previous version of the stack of the CloudFormation template did not cover. So maybe you need to change a bit so you can add. And then another beautiful thing you can do with the CloudFormation template is that with your CloudFormation template, you can include comments. And we saw how to include comments in your when we were discussing the first topic. So you include comments by using the hashtag for commenting. And commenting generally in code is important because it tells you, it reminds you what that block of code does. That's one. Then number two, that comment can also help other developers or other people that you are collaborating with in doing that project. It can tell them what that block of code does. You understand? You understand? For example, there is this time that we were deploying some stuff, and then because there was an EC2, and then each time we were deploying, each of us, we were in a team of 3. Each of us needed to have their own key pair. So after, let's say, dev 1 did their bit, they included a comment alongside their key pair with a hashtag mentioning that this is key pair for dev 1, then this is key pair for dev 2, this is key pair for dev 3, so that when it now landed on me as dev 3, and now I needed to do my work, and I had my key pair, I knew that when I'm running, I need to comment out. You know, comment out is just to make sure that that line of code is not interpreted as code. You know, that's what we call commenting out. You make sure that a line of code is not interpreted as code. So I commented out the 2 key pairs, the key pair for dev 1 and dev 2, so that it's only my key pair that could be interpreted when it was my turn to run the workload in my company account, in my assigned user account within the company larger AWS account. I hope that one makes sense. So documenting is very important, and things like debugging also very, very important. So the cloud opens up many possibilities. However, it also raises questions about how to manage its power and flexibility, such as how do you update servers that have already been deployed into a production environment? How do you consistently deploy an infrastructure to multiple regions in separate geographical locations? How do you roll back a deployment that did not run according to plan? In other words, how do you reclaim the resources that were already created? And how do you test and debug a deployment before you roll it out to production? Now, and finally, before I say something about rollback, how do you manage dependencies on systems and technologies, and also on entire subsystems? For example, our website that is deployed. Hey, a website that is deployed on top of an e-commerce infrastructure. And I like the fact that they've used our example, an e-commerce infrastructure. So you have a website that is deployed on top of that e-commerce infrastructure. Now, rollbacks are important for many reasons. You know, I told you that there is this thing that we call versioning in development. There's something that we call versioning in development. So you have a version 1 of the application already running in production and working just fine. And then you get feedback from your users saying that, well, there's a bug here, there's a bug there. Or you sit down and then you say, you see, our version 1 was just an MVP, a minimum viable product. But now we want to maybe include another feature. So we are going to implement that. Now, sometimes, and this has happened to us in a team that I was in, sometimes you implement a feature, and then that feature, when released into the test environment, and then now you know in the test environment you've made a replica, or rather you've made a copy of what is already running in production. You come to test this feature, and then you discover that this feature goes to break what was already working in the first version. It like, for example, I think in that case, it brought in an error. There's this error called circular dependencies or something like that. I think devs know that error. And now what we had to do with that is, you see now the reason why you need to test everything before you release it to prod. We had to sit down and then look at what is causing this additional feature. Okay, what is this additional feature introducing to our already working deployment such that it's now breaking it? So after sitting down, debugging, running a few debugging here and there, hapakule. So we were able to find the root cause, and it was actually a very small bug fix, and that was it. That was it. So it's very, very important for you, first of all, to make sure that you have a mechanism in place to roll back to a version that was working. Say, for example, you take a feature and then you introduce it, it passes test, and then it goes all the way to prod. And then in the process of time, you discover that, oh, something has broken in your system. Then you ask yourself, what could have caused this? Of course, the very, very first culprit will be this latest feature that you've introduced, because before this feature, everything was working just Fine. So when such happens, you might be forced to roll back to the previously working version so that your users can continue enjoying your service. Your services can still be online as you work on fixing any bugs that might have been introduced by this additional feature, so that once this bug has been fixed, tested robustly, and found to be working properly, you can then release it again back to your users. I hope that one makes sense. So all this is possible by use of EAC, and the EAC that we're talking about here is CloudFormation. So CloudFormation models and provisions cloud infrastructure resources, and then it supports most AWS services. It creates, updates, and deletes a set of resources as a single unit called a stack. So a stack is everything that you've written in your CloudFormation template, in your CloudFormation template. So everything that you write in one CloudFormation template is considered to be a stack. So it detects changes called drift on stack and individual resources. That's the power that CloudFormation also has. It can detect drift. It can detect drift in your infrastructure. Yeah. Very nice, very nice. Thank you for that, Musembi. I had not seen that. Thank you. Rolling back is a good way of ensuring service continuity. New rollouts come with bugs and complexity. Lamp stack. yeah, I hear you. And Musembi wearing his hat as a QA, if he says that, you can take that to the bank. You can take that to the bank and cash it. Awesome. So, yes, so we are saying that AWS CloudFormation enables you to create and provision AWS infrastructure deployment predictably and repeatedly. You can use AWS CloudFormation on services such as EC2, EBS, SNS, ELB, that's Elastic Load Balancer, auto scaling, and then AWS CloudFormation enables you to use a template file to create and delete a collection of resources which are managed together as a single unit called a stack. Now, the services you've seen mentioned here are just some of the services. It doesn't mean that the other services are excluded. These are just examples. So you can virtually use CloudFormation for any AWS service. All right? Okay, cool. Though you manage your resources through AWS CloudFormation, users can change those resources outside of AWS CloudFormation. And we talked about this. Users can edit resources directly by using the underlying service that created the resource. For example, you can use the Amazon EC2 console to update a server instance that was created as part of an AWS CloudFormation stack. Some changes might be accidental and some might be made intentionally to respond to time-sensitive operational events. Regardless, changes that are made outside of AWS CloudFormation can complicate stack update or deletion operation. And I mentioned that's what we call drift, okay? That's what we call drift. So you can use drift detection to identify which stack resources have configuration changes that were made outside of AWS CloudFormation management. Then you can take corrective actions so that your stack resources are synchronized again with their definition in the stack template. Yeah, for example, you could update the drifted resource directly so that they agree with their template definition. Resolving drift helps you to ensure the consistency. It helps to ensure the consistency of your configuration and the success of your stack operation. So remember what I told you, that it's very possible you have deployed your resources using CloudFormation or any other EAC tool, and then somebody either responding, again, according to the explanation we have here, they are responding to something urgent that maybe they wouldn't go back to the EAC tool. So they decide to tweak it using ClickOps. Now, that drift will not be captured in your template. So to make sure that that is captured, you can come back once CloudFormation has flagged a drift. You can come back to your template and then update it to mirror the changes that were made via ClickOps. That's how you reconcile. Yeah, that's what you reconcile what is there to what is in your template. I hope that one makes good sense. Now, this AWS cloud terminology, CloudFormation terminology. So we have AWS CloudFormation. This is the logo or the icon for AWS CloudFormation. Then we have a template. This basic definition of resources to create specified in JSON or YAML. So you can use either of these languages. You can write it in JSON or YAML. Then the instruction, what this template can do, this template can create resources, it can update resources or delete resources. So then a stack is a collection of AWS resources. Stacks are the instantiation of a template. Templates can be instantiated multiple times. To instantiate is just to run. When you run it and then it's fully running, these are the resources that are being spun out. And you can see actually the resources here, there, because we have issued a create, an update, or a delete command to AWS. So inside our VPC, we'll have the following being created. We have our DynamoDB, we have our RDS, we have our instances inside the VPC. Outside the VPC, because again, remember, S3 is not region specific. So outside, we have what? We have S3 Glacier, and we have buckets with objects. You see, all of these have been created for you. Okay, so you can read that. There is nothing much there. Then now for the template structure, when you're writing your CloudFormation template, so you will need to have the following. You'll need to have parameters, mappings, and resources. Then under resources, you can see we have what? EC2 instance. Then the property for this EC2 instance, you can have a user data, for example. You can have metadata, you know, init is initialized. Then now see, we have packages, groups, users, resources, files, commands, services. Then CloudFormation wait condition. So this wait condition tells you that for this to work, for the next step to work, it needs to depend on EC2 instance. So the EC2 instance must first be created before this one, before the next level runs, okay? And then AWS CloudFormation wait condition handle, then you have your output. So your output is like it will print some stuff out. But now let us look at this explanation. Parameters, this one inputs into template. Mapping, static variables, typically the most recent Amazon machine image. So if this is for creating an EC2 instance, so this one will be it will be the static variable. Let's say, for example, the AMI, the most recent AMI that you can find in your account. Then the resources, AWS assets to create. So the assets to create, you can list them here. And then you need custom application to run during startup. So initialization, so it will run. It will run during startup of that resource that you are creating. Then wait condition. This one signals for instance that user data has completed, signal from instance that user data has completed running. So for you to move on to the next step, using this instance, the user data must finish, because maybe in this user data of yours, you are maybe you are installing your HTTPD server, for example. You understand? And then outputs, values of custom resources created by the template, such as URLs, usernames, and others. So all of this can be printed out for you once the template has finished running. Then the explanation I've given is here, all of it. And I'd just like to highlight this wait condition because it's important. Okay, let us start from init. The CloudFormation init resource type enables you to deploy applications, files, and other resources onto your EC2 instance as part of the deployment process. Okay, then wait condition in normal code, let's say, for example, you are writing a Python script, you will use something like await. So it's waiting for something. Then when you are writing your CI/CD pipeline, you can use something like depends on. So you are just telling the pipeline that as you run, when you reach this step, make sure that you pause here and wait for that other step to finish, because this step depends on that step. You understand? So that step must finish before this step runs. You get? Yeah, I hope you get that one. Then now wait condition. The CloudFormation wait condition, a resource type, is used to coordinate resource creation. For example, suppose that a resource has a dependency on another resource, AWS CloudFormation will wait for other resource creation activities to complete before it attempts to create the dependent resource, or the resource that depends on that other resource. So wait conditions enables you to signal back to AWS when your CloudFormation init command finishes running successfully. Like in the example that we saw up there, we needed first of all the user data to finish running completely. Then output is an optional section of the template. The output section returns string values that are created by the template and that might be important to users. For example, if you create an EC2 instance that functions as a public server, you might choose to output the full public domain name server or DNS name of the server to the output section. Sometimes this is important. Again, just comparing this with Terraform, when you're using Terraform and then you have the output block. Now that output block might require, okay, you might want it to maybe to echo the IP of the instance, so that IP can now be used by, let's say, the configuration manager. Say, for example, you're using Ansible. So Ansible will now be able to pick that IP and then use it. And then also for you, to give you just that peace of mind, you'll now be able to see that indeed Ansible is actually configuring the right instance. Sorry, if you remember what we said, IP addresses shows it actually uniquely identifies a resource within the internet. So it will identify your server, and then that server is where you now send your CSE configuration as code to go and do the configuration. I hope that one makes good sense. Now, good. We continue and we talk about edit AWS CloudFormation template. You use an editor that is compatible with AWS CloudFormation or a JSON or YAML editor to use features such as parsing capabilities, automatic completion, and syntax checking. Now, for me, what I have used over and over again, and it continues to work for me, I use VS Code. VS Code, you know, VS Code itself as an IDE has a good support for numerous plugins. So you can have different plugins where needed. You can have plugins for YAML. You can have plugins for JSON. So when you have your JSON file, you are able to see it, and then you are able also to you are able to debug it if it has issues. You are even able to write it, because some of these plugins allows for auto completion. You understand? They allow for auto completion. So here we have been given some examples. You see, we have AWS CloudFormation template editor for Visual Code or Eclipse. So we have that CloudFormation template editor. Then we have third-party tools. Then you have text editor with JavaScript or JSON plugins. You know? Okay. So you'll read this. This is just the same thing. And you can see here you've been given instructions. If you want to use AWS CloudFormation template for Visual Studio, you can just come and click this, and then it will open for you documentation on that. Remember that what we do most as cloud engineers is that we really rely a lot on documentation. You know, we really rely a lot on documentation. And I'd like to implore you guys that even when you start doing your own projects or even start working with organizations, don't take that lazy approach that when you hit a snag, the first port of call is an LLM. Yani you run to Kuzo, or you run to Sub Kuzo, or the brothers to Kuzo. I mean, you run to ChatGPT and friends. No, the first port of call should ideally be what? It should ideally be the documentation. And actually, you can even reference that documentation and point the LLM. You can point the ChatGPT and friends to that documentation and tell them, based on that documentation, resolve this error. It goes and reads for you, and then it does that. I remember when ChatGPT, which version was that? I believe the very, very previous versions of ChatGPT did not have that ability to go and read anything outside of itself. So it had its own limited database where it was running all of its queries, checking, searching, and then giving you answers, of which most of those answers, after all, were hallucinations. So with the latest modifications, you can actually see it going to different places, reading here, reading there. For example, I just wrote a very interesting blog using ChatGPT as my guide. And that's why I call it Kuzo. So I just gave it my thoughts. I told it, this is what I want to write on. go look at the documentation, come and tell me if I'm on the right track. Then we just converse, It's just a matter of chatting with it, telling it, no, this is not what I'm looking for. I'm looking for this other thing. And then we ended up writing a very good documentation, which I will post to, I will tweak it, add my own voice to it, and then post it to my blog, And I remember we told you guys that it's very important for you guys to do what? To build in public and to learn in public. I've seen very few of you writing articles on your LinkedIn accounts, especially for those ones who we are following. Special mention to Ridge, you've been doing a good job, but of late I'm not seeing you right. The person that's really shining nowadays is Leonard. Leonard, good job. Good job. I've been seeing a few things that you've been writing, and that's very, very good. I think it's worth mentioning here, but I know on Thursday we'll talk to you about communities. But it's also worth mentioning here the reason why we normally push you guys to do these writings. There will come a time that you will use these writings to apply for some awesome some awesome offerings by AWS. For example, there is a program by AWS called Community Builders. And you become a community builder because you see the name. I told you AWS with their namings. You are building the community. You are building the AWS community. How do you build the AWS community? The easiest way to do is do what? Share your knowledge. Even if you are a beginner, just posting that you have successfully hosted an S3. You have successfully hosted a static website on S3. That's like the very first project that most CCPs do. Writing a very good and flowing instructional blog on how to achieve what you have achieved. That alone stands out as your contribution towards the growth of AWS globally. So when you do that, and then that window opens, and then they say that now you can apply to become an AWS community builder, you can use your blogs, those blogs. You need to have like 3 to 5 articles or 3 to 5 short videos, which you can now use to showcase your contribution to the community. Then once you apply and then you fill the form and fill everything, they go check. And if they're impressed with what you're doing, they give you the title of what? Community builder. And for community builders, it's a very prestigious program. I'm not in it. I'm not in it because let me just bant because you guys are my friends. Yeah, I'm not in it because I was not very active. I was not very, very active during my CCP days. So that is something that I learned on the job. I learned that it's very important for you to be active and for you to build and write in public. Those who follow me on LinkedIn, you can see the things I do. I write a lot. I write a lot because I'm also positioning myself to apply for that program. That is number one. Number two, just another mention is that AWS also has other offerings. Like there are like 2 very beautiful events that happen every year. 2 very beautiful events. One of the events is called Reinforce. Reinforce is the coming together of guys in the security space. So if you are a cloud security specialist, if you're a cloud security learner, if you are a cloud security engineer, a DevSecOps engineer, all of these guys come together and they congregate in the US for a 3-day summit called Reinforce. So it's a security summit for guys. And I remember this year, there's a friend of mine, there's a very good friend of mine that won a grant to go. And she actually went to the event in the US at AWS's full expense. So AWS covers everything for you and you're able to go. Another event is what we call a reInvent, AWS reInvent. That is like the biggest event. It's like the biggest event and it happens once a year. It's called reInvent. It is during this event that you have partners coming in, AWS staff coming in, AWS leadership coming in, and they do a lot of product launches. So they launch new products, they make new announcements, they even announce new certifications, if any, and it's happening this year. And this one, you also apply for it, and you can only apply for it if you have some stuff that you've written, that you can show that you have been contributing or you've been learning AWS. So when we were insisting that you guys do this, that's what we meant. And just to mention, yours truly actually won the grant this year. I won the grant to go for reInvent this year. So next week, I'm getting honor. Next week, you wouldn't have seen me. Is it next week or next week but one? Around end of this month, I would have been traveling to the US to go for reInvent. Sadly, sadly, it happened that I did not get a visa. My visa application was denied, and so I was not able to continue with that journey. But next year we'll still apply. We apply, you see. So I'm sharing that story now, but we will talk some more on Thursday. But I'm telling you that just to show you the value in building and learning in public. I hope you guys understand. Build and learn in public. And good thing also, it's also worth mentioning that I have like 4 friends that I know that are actually going for reInvent this year. So it is not something. It is not something that it is not something that we are just telling you. We are just hyping you. It's something that we've tested and we know it to be working. No, I did not attack Potters. I did not. Yeah, we keep trying. Yeah, and it's true, Sharon. A win is a win. You know, even winning that grant, it came as a big surprise. 2 years previous, I did not win the grant, but the 3rd year in, I won. And so we will continue trying. And you guys, we've told you that even after you graduate from this, we move you to the alumni WhatsApp group. All of you will move you to an alumni WhatsApp group. And then these opportunities that we are talking about, should we come across them, we tell you there, we tell you the communities to join, because we are invested in your growth. It's not just about the certification, it's about seeing you people grow and become very good cloud engineers. Good. Awesome. That aside, never back down. Yes. Thank you, Habakkuk. Hey, Habakkuk. Habakkuk is a minor prophet. I've just promoted you to a major one. Yeah, thank you. Awesome. Cool. So let us talk briefly about designing templates. And guys, even before we get here, I cannot emphasize this enough. AWS has a lot. It just has a lot to offer. It has a lot to offer. You just need to know how to. And this guidance that we are giving you guys, you might take it as stories at Java, but this is actually real stuff. This is real stuff. You guys, there are guys that we actually onboarded to LinkedIn. There are guys that we onboarded to LinkedIn. They were never on LinkedIn, but now they are on LinkedIn. Please use your LinkedIn properly. Connect with the right people. If you learn that there is this colleague or there is this person that is working as a DevOps engineer, say in Safaricom or at Safaricom, connect with that person, send them a connection request or even just follow them and then see what they are posting. Learn from them, learn from them. And there is someone that came and spoke to us during our restart days, and she told us that, you see, guys, when you see me on LinkedIn, don't shy to come and say hi, and then if you want me to mentor you, come and just tell me that, by the way, I am interested in this field that you are in. This is what I've been doing. Would you mind being my mentor? And that is how you get your mentors. You understand? That's how you get your mentors. Some of you here want to become cloud security engineers. You need to find cloud security engineers on LinkedIn. That's the easiest way to get them. Sometimes meeting these people in real life might be very difficult, but you can interact with them on LinkedIn, see what they are posting, comment on what they are posting, ask them questions, connect with them, talk to them on their inboxes. And sometimes you might talk to somebody like that, and then they say, but there's this new project that I'm doing as a side project. Do you mind collaborating with me? I'll teach you 1, 2, 3s. And don't put pesambele, don't be money focused. I know the goal eventually is to make money, but also building experience is very, very important. You understand? Building experience is very, very important. I hope you guys are getting it. Good. Designing templates. That was a good break even for me. So let us look at designing templates. So AWS CloudFormation has what we call an AWS CloudFormation Designer, which is a visual tool that enables you to create and modify AWS CloudFormation templates by using drag and drop interface. So you can use drag and drop interface for you to be able to achieve what we are talking about. So look at this. This is an example. This is a screen grab from AWS CloudFormation Designer. And please note that when you see these screen grabs, there's actually a possibility that now when you go to your AWS account, you might find that The interface looks a bit different because, again, what we told you about AWS keeps changing things. Sometimes, okay, often making things better. So we have the design surface, and then you have JSON or YAML editor, and then you can also incorporate third-party tools. So we are saying that this AWS CloudFormation Designer is a visual tool that enables you to create and modify AWS CloudFormation templates by using a drag and drop interface. So you can add, modify, or remove resources, and the underlying JSON or YAML will be altered accordingly. So your work is you are adding these resources you are adding them to your design surface, and then as you add them, on the other side, JSON or YAML editor will be adding these resources. It will be writing the code for you. It will be writing that code for you depending on the data serialization tool that you've chosen, if it's JSON or YAML. So it will add that for you. So that is very, very nice. Okay. Then launch and delete stacks. AWS CloudFormation templates can be launched as stacks through AWS Management Console, AWS CLI, and APIs. Remember what we said, how to access your AWS account. Still, those 3 routes can also be used to launch your CloudFormation templates. If an error is encountered when you launch a template, all resources are rolled back by default. So it has that capability to roll back. It has that capability of rolling back all the resources. Then when stacks are deleted, resources are rolled back. You can optionally enable termination protection on a stack. You can do that. You can enable termination protection on a stack. So we have talked about that error, and now that is okay. So that is okay. So to preserve, let's say, for example, an EBS store, an elastic block store. For you to preserve it, when you are deleting the stack, you can set delete on termination attribute to false. So it means that when now you run the delete and you want to delete your stack, it will delete everything and then it will preserve your EBS. Sometimes you don't want your EBS to be deleted because you know the work of EBS. EBS is the persistent store for your EC2 data. I hope you remember that. Now, to preserve a resource, set its deletion policy attribute to retain. So some resources might not be deleted when a stack is deleted, such as an S3 bucket. You can optionally enable termination protection on a stack. So that is very, very important. That is very, very important. Let's look at where are we at? Defining parameters in a template. To define parameters in a template, you will use the optional parameters section to customize your template. You see here we have parameters. I hope you guys can see it here, parameters. Then parameters enable you to input custom values to your template each time that you create or update a stack. So you can have your custom values, like this is a logical name unique within the template, VPC CIDR. Description is CIDR block for VPC. The type is string. The default you have given it its version. Allowed values, not really version. This is the IP. This is the IP. This is the IP, the CIDR. The CIDR, you see it's a /20, and then allowed values, you can see it here. Now, who is that who wants to ban? We can pull seats. Okay. We have returned our seats. Okay. So string. So must specify a supported data type, one of string, number, list, comma, delimited list, a parameter that is specified to AWS or an AWS systems manager. So this one, you can see here, we have said that the type here is string. That's why we are using those double quotes. Okay. And someone tell me, is this JSON or YAML? Just by looking at it, is this JSON or YAML? JSON. Good. Awesome. Good. Kumbe, you people are attentive. Awesome. So you'll read those notes. That is just a repeat of what I've just talked about. Reference a parameter. To reference a parameter, you use the ref intrinsic function to reference a named parameter. It converts to string regardless of the type in the parameter declaration. Let's look at this example. Parameter key pair name. Type is AWS EC2. key pair, and then the key name. A reference parameter, when you are referencing this key name, it will ref what? Key pair name, you see? So it is referencing what? The parameter. So you have to define the parameter before you reference it. You understand? You have to declare a parameter before you reference it. So that is very important. Use the fn ... select, that is double colon. Fn, I believe Fn is function. Function double colon select function to select values from a comma delimited list. Let's look at an example here. Availability zone. Then we have opened our curly brackets. Then we have the function here is to select. So 0, ref availability zones, and then that. Now, remember, when we are talking about 0, when we are counting items in a list, we start from position 0. So position 0, there is something in that position. There is an availability zone that has been listed at position 0. You know, when you are counting items in a list, you start from position 0. So when you have 0, 1, 2, 3. So if you've written here that you want it to be at position 0, then that is what will be, that's what you will be able to get. Again, when you read through that, you will be able to deepen your understanding of what I have just said. Next, ref and other intrinsic functions. So the ref function enables referencing components that are defined in an AWS CloudFormation. I've told you, you must you must define whatever you want to reference must be defined first. It is necessary for referencing parameters using maps, joining strings, and using other functions. For example, my EIP. Who can tell me what EIP is in full? What is EIP in full? What is EIP in full? Somebody? What is EIP in full? Are you sure? What is EIP in full? Okay, if you did not know it, EIP in full is elastic IP. E is for elastic IP. So my elastic IP type, AWS EC2 elastic IP, properties instance ID, ref, my EC2 instance. So we are referencing my EC2 instance. But let me also ask you a question. Let me ask you a question. Where is that question? Let me see. So yes. Now, having told you that EIP is elastic IP, what is the difference between static IP and elastic IP? Or let me even make it simpler. What is the difference between normal IP and elastic IP? When you're talking about an EC2 instance, an EC2 instance with a normal IP and an EC2 instance with an elastic IP, what is the difference between the two? Yes, elastic. Oh, Gideon. Let me check something. Give me just a second, guys. Oh. Let me check something. Yes. Let's see. Elastic IP, AWS. I've told you, when in doubt, always look at the documentation. Let's see what the documentation has to say about it. Give me a second, guys. So actually, my first question was wrong. So an AWS Elastic IP is a static public IPv4 address that you can allocate to your AWS account and then associate with an EC2 instance. Its main purpose is to provide a stable, fixed IP address that remains constant even if the instance is stopped and restarted, which is crucial for services like DNS configuration and load balancing. You can quickly remap the EIP to a different instance to redirect traffic, which can be used for instance failure masking. I think this is important. Let me just copy the whole of this and paste it for you guys. But thank you guys for your attempt. The attempt was good and it has been noted. Control V. There it goes. So, yeah, yes. So the normal IP is what changes. The Elastic IP does not change. Yeah, good. Awesome. Awesome, cool, good, cool. So let us resume. Where is my notes? I hope you've seen that. So it's very important for us to remember even the things that we did in the first weeks that we were together. Okay, cool. So my Elastic IP type, we have Elastic IP properties, you can see there. So we are told here that you need to be careful when you use the ref function. The value that is returned by ref is dependent on the resource that is supplied to it. For example, using ref function on an S3 bucket returns the bucket's name, but using it on an Amazon SQS, simple queue service, queue service returns the queue's URL, So ensure the resource that you reference with the ref function returns the correct identifier in the current context. In the example, the ref function returns the instance ID of EC2, and it is appropriate to assign it to the instance ID property of the AWS EC2 IP object. So that is very, very important. Again, you guys, you also need to know the difference, because this one also confuses people in exams, the difference between SQS, SES, and SNS. Okay, so you need to know the difference between SQS, SES, and what am I typing? My Lord. SQS, SNS, and SES. Amazon, SQS, SNS, and SES. Please make sure that you know that that question, you can get 2 to 3 questions around surrounding these 3 services. So you need to know which one does what. Okay? You need to know which does what. Cool. Good. All right. Where is my mouse? Here it is. Good. Then we have what we call pseudo parameters. So additionally, you can use ref intrinsic function to access information about your runtime environment. Example, region, stack name, AWS account ID. Pseudo parameters are predefined, so you don't need to specify them in parameter section of your template, meaning that you don't need to define them because they are already predefined for you. So look at that output. Outputs, my stack region. Then you have value, and your reference, you want to ref AWS region. So when it outputs, it will show you the region in which your stuff is running on, or your workload is running on. So that is very important. Define mappings in a template. We said after parameters, the next thing that we are looking at is mapping. Remember what we talked about when we are looking at that fast screen grab? Fast screen grab. We saw that after parameters, we had mappings. So to define mappings in the template, define lookup tables of name value pairs in a 2-level map. Combine multiple mappings tables together to create nested lookups. And this is also used. This is also used most commonly to look up current AMI values. Remember, when we were talking, was it yesterday or which other day, when we were talking about creating an using an AMI builder to launch, let's say for example, to launch our instances. You see, it is possible for a cloud engineer to define or rather to hard code the AMI. Maybe you've gone to your account and you've seen that this is like the latest AMI for the Ubuntu OS that I want to use in my workload. So I'm going to pick it as is. But things happen and AMIs expire. You know, remember we say that AMIs have an expiry date. So if you have used it for quite some time and then it expires, then you risk a chance of having workloads that are no longer supported. So, you know, it's just common when you hear that something has expired, like for example, guys on Windows 10, you heard Microsoft say that, oh, they have stopped support for Windows 10. So it means that any bugs that you find or any bugs or vulnerabilities that hit that operating system might not receive a fix from the official vendor that actually released the first version of that operating system. So it's very important for you to make sure that your workloads are running with the latest AMI version that is supported and that has bug fixes and improvements. So what you do when you are writing your CloudFormation template, instead of hard coding your AMI values, you can actually have it as a variable. So anytime you are running it, let's say, for example, you are in an organization which has this template that they've been using and has been working for years. And so they decide that now you are now the new cloud engineer and they tell you that please go and spin up a new environment. You'll be able to take that because the AMI value is not hard coded. When you run that template, then you will discover that it will go and read within the account. It will go and read the right AMI and pull it and then use it. You know, the most current AMI, it will read it and pull it. That's a very, very important thing to note. That's a very important thing to note. So look at this mapping example. So we have mapping such as AWS region to AMI. So we have US is to 1 and you have AMI for it. You have US is 2, you have a different AMI to it. You have US West 1, you have a different AMI, you have West 2 AMI. Then you have to remember, this is an exam question, that AMIs are normally locked to a region. You know, they are locked to a region. And that's why sometimes hard coding these values without specifically or expressly mentioning the region to which, the region to which they apply can be disastrous, especially if it is a shared, if it's a shared template that you are going that others are going to use. Because you will find that, let's say, for example, I'm working on something with Basil, and then I run mine on US East 1 and then it works perfectly. Then Basil wants to do his work maybe on in EU West 1, and then he tries running the same AMI and then he starts finding, okay, he lands himself in problems. So the solution around that is always to map. You know, you map and say, for US East 1, we are using this AMI. For US West 2, we are using this. For this, we are using this. You know, so look at that image ID. You can use a function called find in map AWS region to AMI, and then look at that reference. The reference is we want to know the AWS region and the AMI. So you use that intrinsic function for lookup. So you are looking, it's like you are searching to know which region, okay, which AMI is mapped to, okay, yes. Which AMI is mapped, let's say, to the specific region that I'm in. Let's say, for example, I'm in US West 2. You understand? So that I use the right AMI. I hope you have understood that small topic. It was quite a mouthful. That small explanation was quite a mouthful. Defining resources in a template. Now, we have cleared with parameters. We have looked at mapping. Now we move on to resources. Give me a second. Aha. the type of resources that you are declaring. So we are looking at the type of resource that you are declaring. That is very, very important. That's number one. And then you can require the creation of a specific resource to follow another resource. Remember what we said, depends on. Then properties for a resource, you can also add that one as an additional. So look at this. So we have a resource here as my RDS instance. The type is DB instance. The properties allocated storage 5. So this might be 5 to the value that it comes with. Is it a GB, a TP, or whatever? Then look at this. After this instance, we now have our web server down here. Then the type is EC2 instance, depends on RDS instance. So RDS instance must be created first before this is created, before that is created. And when you read through this, it will show you that our EC2 instance, which we have named web server, has a dependency on the RDS instance. The database must be created before the applications that will run on the web server can use it. So it's very important that we create what first? We create the RDS. Although the AWS CloudFormation service performs some sequencing of resource creation tasks automatically, these rules change as support for new resources type is rolled out through the system. To help ensure a consistent sequencing of resource creation tasks, it is best to practice the use of depends on attribute. Okay? Yeah. So what you are being told here is that CloudFormation, similar to Terraform, is intelligent enough to know that I need to create this before this. For example, I need to create a VPC before I create the EC2. That one it knows. But just to give you that peace of mind, you can add depends on, especially in things that are not really native. Yani they don't have a one-to-one relationship. Like, a VPC and an EC2 instance, that the VPC has to be created because the EC2 instance will need to be hosted inside the VPC. Inside the VPC, So yes, and okay. Also, our public subnet will need to be created before, of course, the instance that goes inside that public subnet. That is a one-to-one relationship. But these other ones, that now you have a different service called RDS and a different service called EC2. But these two at some point will need to communicate. Why? Because guys that are accessing our systems through the EC2 instance, whatever they are running, maybe they are running the put, they are running the get, they are running they are running, okay, they are doing their put, their request, they are sending the request. Let me put it that way. They are sending the request to the database. So that database has to be created first before the web server is created, just to make sure that everything runs nicely. You understand? To ensure that everything runs nicely. CloudFormation init. We saw this one. We are told that resource type that provides access to metadata from EC2 instance. So when you see CloudForm init, this is a resource type that provides access to metadata from EC2 instance. You can use it with cfn-init helper script. So cnf-init helper script, this one reads template metadata from AWS CloudFormation init key. With this information, cnf init can do the following actions on EC2 instance. Remember, CFN is CloudFormation. That is the short form for CloudFormation. So what can it do? It can install packages. It can manage groups and user accounts. It can write files to disk. It can run commands. It can enable or disable services. And it can start or stop services. That is what that script can do. That's what that script can do. And you have a very nice documentation here, deploying application on EC2 with AWS CloudFormation. So you can check this. It actually even guides you and gives you steps by which you can accomplish that task. And then, for an example that shows you how to use CFN init to create a Microsoft Windows stack, refer to bootstrapping AWS CloudFormation Windows stack. What were Windows mmefikiwa? You have not been excluded from this. Now look at this script. We have my instance type is instance metadata. We have the CloudFormation init, web configuration, packages, sources, groups, and commands. So all of this, when you run that, it will do a lot of good things. And then we also have a link to the documentation on that command. Okay. User data versus CloudFormation init. So we have used user data before when we were launching an instance in one of our labs. We used the user data where we created an HTTPD server. So use user data in AWS CloudFormation script file as with individual instances offers greater control, offers greater potential for error, must be more cautious. So you can actually take the same script, the same user data script, and put it in the block where you are creating your EC2. So you can add it there. But now, here comes CloudFormation init. Can roll back automatically on failure, easier to manage than user data fields in CloudFormation template, and then can attach metadata within the template. Config sets allow multiple configs in a single CloudFormation init. So it allows you, it gives you flexibility using the init script. It gives you better flexibility compared to us focusing on having our user data in our CloudFormation template. And those notes are yours. We've just talked about it. And again, we had seen what wait condition and wait condition handle are. We saw them in that example. Yeah, we saw them in that example. So wait condition blocks the completion state of a stack until wait condition handle is called or the timeout limit is reached. You can specify the number of successful signals that must be received before wait condition is fulfilled. The default is normally 1. You can signal success or failure by using CFN signal command. You can use CFN signal command. They've mentioned all of this here, but this stuff is a bit advanced for you guys at this stage. At this stage, this is a bit advanced, but you will meet it a lot right from your, for those who will decide to do developer associate, you will come across this when you're handling infrastructure as code. So at that level, it is handled in some good depth. Okay, it's handled in some good depth. Then, so this is just how you can specify a wait condition handle. You have your web server wait handle type, and we know wait conditional handle. Then you can see the type is wait condition, depends on web server instance properties, handle reference. Then you have your timeout. Timeouts are normally declared in seconds. So if you see 3600 seconds, divide that by 60, it gives you how many minutes? 60006. That's like 60 minutes, about an hour. Is it so? Let me see. People of mathematics, what are your maths? 3600 divided by 60 is what?
It is 1 hour.
It's 1 hour, huh? Okay, good. This is quite a long wait time. It's quite a long wait time. So, signaling awaiting condition. So you have your user data function is base 64, function is to join. Then you have your bin bash. Yes. Then you have all that has been written there. So that is the condition that will be running. That is what will be running. That's like the script that will be running. And then if that is fulfilled, things move on as they are supposed to move. And sometimes you might also hit an error. Okay. Hope you have gotten that. Defining outputs in a template. So output returns value for resources that were created as part of the stack. Use intrinsic function to obtain values of a resource in a stack. For example, here we want to get our website URL. Description is the URL of the website. So the value, we are going to get it as an HTTP:// followed by the URL of our website. So it will get the attribute from the Elastic Load Balancer, and then it will look at the DNS name. All that explained properly right there. So there is some additional CloudFormation stack options. So you can specify additional options when you create an AWS CloudFormation, such as preventing rollback on failure, which is not advisable in most cases. Setting a stack policy to control stack updates, that is important. Enabling termination protection, that's also important. So AWS CloudFormation, you see, we have a simple command here that we can run. We have this, and then it's telling you here that on failure, do nothing. On failure, do nothing. So there is no rolling back. Okay. So, anything important to highlight here? No, we've just talked about it up there. So that is cool. That is cool. Then override for failed update rollbacks. You continue rolling back an update to your stack. Continue rolling back an update to your stack even after rollback has failed and is in the update rollback fail state. Perform an override. So by overriding, you are remedying the cause of the failed rollback. And then you're instructing AWS CloudFormation to continue rolling back the update. And again, there are these things that we run. These are commands. So this is a command that you can run on your CLI. So remember, we talked about connecting your CLI, your AWS CLI, such that you can now access your account programmatically. Personally, when it comes to running CloudFormation, I like running them programmatically. You saw that there were different ways of doing it. There was the SDK option, there was the CLI option, and there was also the AWS management console option. So I prefer using CLI because in case there is a problem, I can just whip a command, use that command, and just get everything back in order. So you can see we've been given here this command, AWS CloudFormation, continue update rollback, stack name, existing stack. So you give the stack name here, the stack name, the way you have named the stack. So you can give it there. So that is important. That is extremely important. That is extremely important. So you can instruct AWS CloudFormation to continue rolling back an update to your stack even after the rollback has failed. Some common causes of a failed rollback include changing a resource in your stack outside of AWS CloudFormation. You remember that? That's what we call drift. Insufficient permissions, limitation errors, or resources that have not stabilized. So all that. So that is very, very important. Change set. Change set shows the proposed changes to a stack before any implementation. AWS CloudFormation compares submitted changes to the stack. Engineers can view the changes to see what resources will be added, modified, or deleted. The change set can then be applied to the stack to implement the changes. So an interesting thing here is that there is something similar to this in Terraform. We call it the plan. So when you run Terraform, you start with a command called Terraform init, which initializes. Then you say you run Terraform plan, I believe. So Terraform plan, it will show you once the initialization is successful, it will show you the various resources that will be created. It will list them for you in your CLI. So you'll be able to see if it's an EC2 instance, it will be created. If it's an S3, it will be created. If it is a VPC, it will be created. If it is an ECS, it will be created. So you will be able to see all of them just before you run Terraform apply. When you run Terraform apply, it now applies that plan. It applies that plan, and then it provisions those resources. So you have your original stack here, and then you are creating the change set. Then you have change set, and you view the change set. Once the change set is good, if the change set is good, you can then let it execute, and then CloudFormation will update your stack. But if it is not good and you want to change a few things, you can go back to step 1 and iterate the same process until you get what you want before the build. So you are not totally helpless. You can always change a few stuff here and there. Okay, good. So AWS CloudFormation best practices, planning and organizing. You need to organize your stack by lifecycle and ownership. Reusable templates to replicate in multiple environments. For example, you can have a dev, test, and production environment. So you can use that reusable template across those environments. Then you also need to verify limits of all resource types. You need to verify limits of all resource types, because as you as you declare that this is what you want to create, you need to know what are their limits. Don't force if you try to stretch limits of certain resources, those resources will not be created for you. They'll not be created for you. So that is very, very important. Then creating template. Do not embed credentials in your templates. The same way we said with code, when you're writing your code, please don't embed credentials. Use parameter types that are specific to AWS. Use parameter constraints, and then you can use init to deploy software applications on EC2 instance, and validate templates before you use them. There is something that we run. There is a command that you run to validate your templates for CloudFormation. There's also a command you run to validate Terraform templates before you finally run the build, the commands to build or rather to provision your infrastructure. Okay, good. Managing stacks. Manage all stack resources through AWS CloudFormation. Create change sets before updating your stack. Use stack policies and use AWS CloudTrail to log AWS CloudFormation. You can also use code reviews and revision controls to manage your template. So these are best practices when it comes to managing your stack. And I believe these ones are self-explanatory. If you need additional notes just to understand it better, you can read through this because it is quite quite good. I think I really like these notes, because in as much as this was meant to be just an introduction, but AWS has really gone up and beyond, just up and above just to make sure that you have all the information you need to have a good understanding of CloudFormation. So you'll be meeting this service again and again from right after your exam, when you get into your postgraduate material, and then when you move on to the associate level certifications, professional level certification, and specialty levels. This is one of those services that will be featuring predominantly, because it works hand in hand with almost all AWS services. I need a guy to unmute and read these key takeaways for us, please.
Okay, let me read.
Thank you.
AWS CloudFormation enables you to create and provision AWS infrastructure deployments, predictability, and repeatedly. Two major terms of AWS CloudFormation are templates and stacks. If an error is encountered when you launch an AWS CloudFormation template, all resources are rolled back by default. Parameters enable you to input custom values to your template each time you create or update a stack.
Thank you so much. Thank you so much. Thank you so much for that. So remember what we said. We said that rollback is initiated by default. But in case you had said that you don't want the rollback to happen, it won't happen. And we also say that in as much as rollbacks are supposed to happen by default, at some point, it might, even without you saying that you don't want rollbacks, the rollback might fail. If rollback fails, there is a command that we've seen in the notes that you can run just to trigger a retry of the rollback process. So, guys, that is CloudFormation for you. That is CloudFormation for you. So, yes. So, any questions? Any questions? No, we will not do the lab right now. The goal here, I told you that we are not going to do the whole lab in class. It's just to walk you through, just to show you what is expected. Maybe read the instructions together, understand what is expected and stuff like that. We are not doing the labs here. This is not week 1. Week 1, week 2, week 3, that is when we are doing the labs in class. But from here onwards, you guys can do these labs in your groups, or you can do them individually. Okay, good. Thank you for the question, Gideon. So deploying lab automation, we are doing lab automation with CloudFormation. Someone please unmute and read this for us so that I also get my my throat to relax kidogo. I've talked a lot. Somebody?
Hi, Patrick.
Hi.
I'll read.
Okay, please do.
Deploying infrastructure in a consistent, reliable manner is difficult. It requires people to follow documented procedures without taking any undocumented shortcuts. Plus, it can be difficult to deploy infrastructure out of hours when less staff are available. AWS CloudFormation changes this by defining infrastructure in a template that can be automatically deployed even on an automated schedule. This lab provides experience in deploying and editing CloudFormation stacks. It is an interactive experience requiring you to consult documentation to discover how to define resources within a CloudFormation template. The lab will demonstrate how to deploy an AWS CloudFormation stack with a defined VPC and security group, configure an AWS CloudFormation stack with resources such as Amazon S3 bucket and Amazon EC2, terminate an AWS CloudFormation and its respective resources. The duration this lab will require 45 minutes to complete.
Awesome. Thank you so much for that, Abby. That is awesome. Thank you. So you have seen there has been a mention of what we've been saying over and over again. Always consult documentation. So the lab provides experience in deploying and editing CloudFormation stacks. So if you have been raring to go, you have been saying, oh, I really want to get my hands on this tool and test it out, you have a safe environment to do it within the lab environment. So everything that you are deploying here will not incur spend as long as you're doing it in this environment. And as you can see, the steps are very nice. Deploy a CloudFormation template, deploy a CloudFormation stack. And then you can see we have a VPC and we'll have a subnet. You can see we have our lab VPC public subnet. We have an internet gateway. And then now you've been given all the steps that you need to follow, okay? You've been given all the steps that you need to follow. You've also been given the files that you need to check. There is this template that you will download. Maybe I'll show you this. Let's just look at this together. Give me a second. Let me get it. Where is it? Open with. I'm going to open it with VS Code. So give it a second. So let me share this new screen. So I hope you guys can see this template. So this is our template. And as you can see, we have the version of the template. We have the name of the template. Then we have the parameters, and you can see what we are having here. We have the VPC CIDR. We have the public subnet CIDR, okay? And then under resources, you can see we have the lab VPC. We have the internet gateway. We have VPC to IG, internet gateway connection. You know, it's always important to make sure that you've attached that internet gateway that you've created, you attach it to the VPC, you know, and then public route table, you can see public route table is here. Then the public route is defined below it. And then you have the public subnet. You can see the public subnet, and you can see, then you can see the public route table association. So that is also important. And then app security group. Then the security group is here. You can see it's referencing the VPC that we had already created earlier. And then at the output level, you can see we want to see the lab VPC security group, so that will be echoed out, you know. Yeah, so that will, this is like the simple starting template that you guys will be using in the lab. Okay, so just download it and then open it with your favorite editor. Personally, my favorite editor is VS Code, and good thing is that this VS Code itself, and terminal, at the terminal section, I had already created that association, you know. that I had already linked it to my AWS account. So if I was doing a personal project, I will do that. But because you guys are doing labs, you are doing it as a lab, you will follow the steps exactly as they are. So if they tell you open and then edit this and edit this, save it and then re-upload it, you will do all that. You'll do all that. And was it this lab? Let me see if that step is here. Yes, now you see now what you guys will be doing here. You will be okay, let me share a different screen. Sorry for that. What you guys will be doing in this step, you'll go to your AWS console, check for CloudFormation under services, and then create stack, and then you'll upload that template file, the template file that you have just downloaded from the lab. You will upload it as is, and then you will now be able to see everything run. You just follow all the steps, create the stack, you'll see creating process. Then that saying that you need to add an Amazon S3 bucket to the stack. So you have been given the steps. So you should edit task.1YAML file you downloaded earlier to include the S3 bucket. So you will be shown how to. So when you go to the documentation, you'll see the snippet of how to create a bucket. So you just copy that snippet as is and come and include it in your YAML file, in your CloudFormation file. All right, in your CloudFormation file. And then after you've done that and you've saved it, you can now then re-update it, re-upload it again. After you've re-uploaded, click on update stack, and now it will update your stack. And then you can now go on and now even add an EC2 instance to the stack, follow the same process written down there. And then when you're done with everything, as a best practice, always remember, when you're done experimenting with AWS services, please tear them down to avoid them incurring spend. Okay, so you can do that one also in this lab environment, but also when you finally have your own account and you're doing your own portfolio projects, always make it a habit of tearing the resources down to prevent yourself from incurring spend. So that is what you guys will be doing in this lab. And the other labs, you can also just go through the instructions and follow those instructions. And I believe you guys will be okay. You guys will be okay. Okay? All right. Cool. So that one brings us to the end of our class for the day. But before even we end, let me see if I can make a quick mention. But it's just a simple thing. I did not see much that I can say about troubleshooting because we've already talked about how you can troubleshoot. I've talked about the codes that you can use. Yeah. Yes, so I've talked about the codes that you can use.